when I look at the project, I'm not seeing as many contributions from people.
How to survive in this particular
Yeah,
time?
I'm worried for myself too.
What is your perspective on this particular thing? Hello everyone, we have with us Yadu sir, Yadudan Vijay, who is a robotics engineer and also has a lot of experience in the field of robot operating system. So hi Yadu sir, how are you?
Hey, Aryan, I'm doing good. Thanks for having me here.
Yes, thanks a lot sir for joining for this podcast. So like without wasting much time, I will tell Yadu sir to introduce himself.
Thanks, Aryan. Hello, everyone. My name is Yadu Nand. I go by Yadu for short. I'm a software engineer, and I've had the privilege of working on several open source tools for a few years now, particularly frameworks like ROS, Gazebo, and OpenRMF. I've had the privilege of actually leading the release of one ROS distribution called Iron Irvini, and I continue maintaining ROS Rolling as its current ROS boss. A few years ago, I started working on the OpenRMF project and was a core developer on the team. Since then, I've had the opportunity to work on other aspects of ROS, especially on the middleware side. More recently, I worked on supporting a Xeno-based middleware in ROS 2 called RNW Xeno. And as part of my open source maintainership duties, I get the opportunity to interact with developers, interact with communities, and kind of set the roadmap for the next ROS release and work on these exciting features. So I'm really excited to be here. Thanks for having me. And yeah, let's jump right in.
Oh, that's really good. And as you said about your journey with the raw stuff, like you are working on OpenRMF and also you have contributed to the ROS distribution as well. So more of your work is related to the robot operating system or else the other robotic stacks as well. Like just integrate those software stacks on the hardware or else it's open source contribution type of thing that you do inside Intrinsic?
Yeah, good question. I started working with robots almost 8, 9 years ago, and these were industrial manipulators. And most of these
Okay.
manipulators come from different OEMs. And each OEM will provide their own robot controller as well as a teach pendant. And typically, you use the teach pendant to program these robots.
Right. The normal robots that we control in industrial robotic arms, likewise.
And the problem there is every robot would have its own interface and perhaps its own language and quirks in programming. So I started with programming there, and what I quickly realized was maintaining each of these stacks gets really complicated and challenging. And it doesn't allow you to write modular software. If I wrote a program with one robot at some time, I have to rewrite that program for a different robot. So this is how I got into ROS to begin with, because ROS to me provided this abstraction between the hardware and the logic. So I really fell in love with it, and I got deep into ROS and had the privilege of working at Open Robotics for many years before Intrinsic. And so the nature of my work usually revolves around writing software for hardware. But more recently, as I've gotten deeper into ROS, I've started working on more of the core elements there. And so the nature of my contributions these days are perhaps in one or two core packages. But I know behind the scenes, I'm still working on using these packages. I still see myself very much as a user and like a consumer of ROS, and definitely use it for all my projects, both at Intrinsic and outside, as well as helping promote it while doing the same.
Mm, right, because we have to use as well those packages because unless and until we are not deploying on some simulation or else hardware, we are not able to see what is really happening or else there are some bugs or not with the packages. That is also
Absolutely. Using it is super important.
exactly. But one of the question was regarding, as you said, you are developing for the open source, creating new packages at a backend level. Like we use the packages, that is the different thing. But I think
Yes.
you develop the wrappers for it so that we can use those packages directly. So for that particular, let's say creating a wrapper, so do you need any kind of use case for that? Because at the end, we are creating a package for deploying on a particular robot that might be in the simulation as well. So how do you figure it out? How to proceed forward with that?
Yeah, good question. If you think about ROS, what it really is an SDK to enable distributed robotic applications. So one way to write these robot programs is to just have one giant piece of code that does everything from perception, manipulation, control, etc. But what ROS does is it provides this SDK to let you split up this program into smaller programs, right? Each program does one small thing, and they all exchange information over some middleware or transport. At the core of it, ROS consists of 350 something packages. And what that core enables is this that you can use to write robot applications. It gives you the ability to generate custom interfaces and then consume these interfaces in a variety of different languages, Python, C++, Rust, etc., to then be able to write these distributed programs. So at the core, we're not thinking so much about applications, but we are mindful of applications when it comes to performance requirements. We obviously can't use certain frameworks that are going to increase the overhead. So when we're developing elements of the core, we're very mindful about how ROS will be used. But we also get a lot of this information from projects in the community. So if you look at projects like ROS2 controls, nav2, MoveIt, OpenRMF, etc., these are all applications built on top of ROS. So they and their demos serve as reference applications for us. So when we develop new features, we're always testing against these reference applications, if that makes sense.
Right. That was good explanation, I must say, like, because we need any kind of reference application. Let's say if we want to control a robotic arm, I think MoveIt is the best way to test your arm inside simulation, and even on, let's say, hardware as well, because we are also trying to build a robotic arm, which we are trying to use MoveIt on that. So that's really good, because for a startup who is just starting out, so we can't use a robotic framework which is paid, because already we are spending on the inventory, and it's hard to again spend on the software where we can't make it optimized as well, like as per our requirement. So I think to make any certain changes inside that particular application, or else, as you said, reference application, where we can build our own packages and also make it flexible at the same time.
It's really good to hear that it's able to accelerate your development.
Right. And for the, let's say, if someone is just getting started with the operating system part. So when I started with the ROS part in my undergraduate, actually, then I was not knowing we also have to do the programming of it, all those things. We were only relying on the nodes, topics, services, actions. But later on, I figured out we can also create our own nodes using ROS2. Then I found out DDS as well. There is some communication layer behind ROS. So likewise, we got familiar with it, but that was a kind of trial and error method, like solving some errors and then getting inside these particular things. But what is your perspective on this particular thing? Like, how we should move with the learning of ROS? What might be the best way, or else an optimal way, I will say?
Yep. Honestly, what you've described is most people's journey, I feel, with robotics and ROS.
Right.
Either they get into some student project, or maybe it's at their workplace, or they've heard about it somewhere and they want to try it in their free time. And they often go about trying to do a project to learn. And I think this is the right way, learning from doing a project yourself. But at the same time, supplementing it with some dedicated time to learn certain topics would be very useful. For me, for example, I come from a mechanical engineering background. Throughout my study, I was still doing some mechatronics, some microcontroller, Arduino programming, Raspberry Pi here and there. But certainly, I did not have the understanding of networking or software systems, which I eventually needed. But what got me into this was the ease of seeing hardware move, and seeing it move in software first in simulation, and then knowing that in hardware it's going to be similar, or at least the performance might be slightly different, but the way things communicate, all of that will remain same. So I think what I would recommend is spending some time looking at our documentation to understand some basic concepts of, we have these topics, services, actions, etc. How do they actually work underneath? What do they need? How do you define these messages? Getting a little bit deeper into networking and what exactly is going on. For some users, they may come from different operating systems. A lot of ROS, at least the tier 1 operating systems, are Unix-based. So some flavor of Linux, likely Ubuntu. So they might need some ramp up over there to get familiar with it. So I think there are many aspects to it. So think of learning ROS as learning a lot of other fundamentals before you can even get into using ROS and writing software for robotics.
Right.
So you'll have the opportunity to learn this breadth of topics: networks, terminals, computing, build systems. How do you compile code? What does it mean to have shared libraries that dynamically link against one another? So I think you get the opportunity to learn a variety of different topics before you can actually start writing software for robotics. And then there's the whole robotics aspect to it, right? You want to try a path planning algorithm, a SLAM algorithm, or maybe just a driver for your camera or your robot. So that's when it really gets into the robotics stuff. But my advice would be, start with the documentation and center your approach around a project, right? Find a good project and learn around this. And what I would request is for the community or people like you who've gone through this journey to submit some kind of tutorial or documentation to our website. I think people sometimes are hesitant that I've done some small thing. How is it going to benefit others? But honestly, it's not. It's going to have a huge impact on everyone. So you've gone through this experience. So if you and your team could submit an official tutorial saying, hey, use this project to get familiar with ROS, I think this would be extremely valuable.
That's actually a very good point. I'm just noting down what you said. We can work on it. Actually, I am working on such a project using autonomous mobile robot and a robotic arm, of course. And if it becomes good on the hardware level, can we also submit for the hardware part? If it works for the hardware, that is also good then.
That would be even better, actually. If the hardware is accessible, people can try recreating it themselves. This has huge.
Perfect. Definitely. And as you said, that particular point, we should focus on the fundamentals of robotics, because what I have seen, some people directly jump to the ROS2 framework without knowing the basics of robotics, like how to write a code, let's say, because we write a node, but that is nothing but the code itself. But the structure changes. That's the only thing. But if we are not familiar with the basics, let's say the transformations, there is one thing like TF frames in the ROS. So that is nothing but the 2D and the 3D transformation concept, TH parameters for the robotic arms. So likewise, if those concepts are fundamentals are clear, then ROS is, I think so, definitely going to be very easy for the people with good robotics fundamentals.
Absolutely. And you can use it as a tool as you're learning these fundamentals. When you're learning about kinematics, dynamics, transforms, etc., why not try it out with ROS? Write a small code, publish the transforms, open up RViz, see how it's performing. All this would be great tools to augment your learning. Of course, once you start writing code that's targeting productions, you may not want to rely on your own code for these things, not because it's bad, of course, but because there may be some edge cases, or maybe there's no ICD pipeline to test changes, whereas open source frameworks out there for kinematics, dynamics, transforms, they might be better maintained. So there's opportunity there to piggyback on work that people have done. But it's going to be important that you understand underneath how it works. So it's good for you to have your own understanding, for you to prototype using your own code and scripts. But when it comes to using frameworks, I think look for really proven technologies out there.
Definitely. That makes completely a different way for learning the ROS. So for the people who are interested to start with ROS, I think this is the best way to move forward with learning the concepts and then applying the things. As you said, we can just use ROS for checking the things that we got just learned with those particular things. We can just implement practically. So,
absolutely. So like I said before, at the core of it, these 350 packages of ROS, they provide a way for you to write distributed software, but they also provide some tooling to help you with your development. So we have a visualizer like RViz. It's really powerful, lets you visualize a lot of different topics. We have launch systems, testing systems, etc., that can help you develop much faster as well. And on top of this, the community has built very powerful capabilities, and most of it is open source. And what I highlight about these capabilities is anyone can contribute. There's nothing stopping anyone from creating a ROS package and actually releasing it on the build farm so that someone else can apt install that package. All of this is completely doable. And it doesn't matter how amazing or production ready or whatever your code is. I'd encourage everyone to try this out themselves, get familiar with releasing a package and putting it out there for people. And I assure you that once you start seeing people using your package, this becomes like a drug. Really, you feel a sense of belonging. You're contributing, someone's giving you feedback, or they're finding ways to improve your code. It becomes really contagious.
That's good, actually. Open source contributions, we have a very good point, I think so. So, actually, particularly for ROS, because many people try for the open source contribution. Even I tried for GSOC actually in my undergraduate, but still it was a bit late in my fourth year. So I was not qualified for that particular round. But still, it's really good because afterwards also I tried to reach out that organization. Actually, they were trying to build the ROS packages itself, but they said you don't need GSOC for that. You can just contribute after that as well. So that's really good because it gives you experience, and also it's an opportunity to work with the people who are better than you. Let's say I'm not very much an expert in ROS, but if I try to contribute, let's say with you, so I'm going to learn from you at the end. So that's really good.
I think programs like GSOC, the most important thing they provide is the mentorship. There's someone you can reach out to when you face a blocker or for inspiration. But don't let that stop you. You should be able to reach out to the same people and say, hey, I'm working on a project. I might need some guidance. I'm a new contributor or user. I'm not going to bother you a whole lot. Maybe once a week, I'll send you one email with some questions, or maybe once in 2 weeks, I'll send you some questions. I guarantee you most people will be willing to help. It's the same mentors you'll find in GSOC. I'm sure they'll be willing to help, even if you reach out to them outside.
That's actually a good statement. Until you don't reach out to the other people, the answer is always going to be no.
And I would say the barrier to entry is very low for open source robotics. And like I said, anyone can develop a package, share it with people, get some feedback on it. And most people should feel comfortable trying to address issue tickets that are open on core packages as well. I think most of us in the project management committee, we're actually waiting for more contributors to come, and we're ready to do more, etc. Think of it as you engage first. You say, I'll take on this ticket, but I might need some mentorship. And I'm sure people will respond. Like people in the core team will say, oh, you take this on, and then I'll review your pull request. And you can use this as an opportunity to get high quality feedback on your development as well.
That's good. So for the students who are searching for internships, I think instead of internship also, they can try to work with the open source community. That's actually going to build your profile in terms of skill development and also building connections at the same time.
I think so too. What's most important is a portfolio, right? What are the projects you've done? Are you able to demonstrate this easily to people? Right. One way to do this is projects, and this could come from a company, or if you have the opportunity, a self-directed project. You just take on something that you want to do and spend some time doing it. And what's important is you're able to document it. And what's a better way to document than having it public somewhere?
Right. That's the best way, I think so, to learn and also implement. And the thing that you said about profile building. So one question was regarding, let's say we are also working on the technical side, but is the technical side enough, or else at what percentage technical side is good with the non-technical side? Because for the students who are interested into the, let's say, job perspective, so for them, job is also important. But at the same time, what I feel is that non-technical side is also important. But at what percentage, if you compare them, technical and non-technical, or else what is your perspective on this particular thing?
To give you a concrete percentage, I would say maybe 60-40 technical, non-technical. Because non-technical is still important, but let's try to qualify what is non-technical. What are we talking about here, right?
Right.
I would say what's most important is maybe one or two things. So firstly, are you able to communicate the work that you've done in the past, right? And being able to do this in simple terms, normal language, no fancy words, you're able to explain what you've done and what the impact of this is, and maybe even why you worked on this, right? That's going to be very important. The other part of non-technical is being able to have discussions with people. Oftentimes, you're going to be working with other people on projects. Being able to articulate your ideas, or maybe even share your questions in an effective manner, is going to be very important. So I would boil this non-technical part down to just communication,
Mm.
right? How effective are you able to have communications, raise certain topics, have discussions, and also start building rapport with other people that you're working with. So I
Right.
think it's certainly important.
That's really important because at the same time, like because we are going to work in a company where there are people, so we should also know how to communicate with the people and how to be with people because we are domestic animals who are going to live in the society. So that is
100%. We build with people and we build for people as
for
well.
people.
Once you build with people, you still have to engage with other people to deploy whatever you built for them.
Right. And that's true. We should work on ourselves and also deliver to the community whenever
Yeah.
we get the time. And it's really good thing. And you
Yeah.
are also into the ROS community and you are contributing a lot to the community. We met at ROSCon last year.
Yes.
Hope so this year as well. ROSCon 2025. We will discuss about it later. But
Yeah.
moving with the next one about intrinsic, like what is the role of intrinsic with ROS, if you can just try to give some glimpse on it.
Intrinsic's mission is to democratize access of robotics to everyone. And if you look at Ross's mission, it's actually very similar. We want to give powerful capabilities at the hands of everyone. To me, when I look at Ross, it's popular, it's pretty powerful in its capabilities, but I feel like one thing that's missing is this deployment journey. Yep, you have access to this open source code. You can build your applications, test it, maybe even do a small proof of concept. But the story of deployment kind of stops there, right? And even developing these capabilities, yes, there are some capabilities out there, but maybe for your applications, you might have to develop some of the capabilities yourself. And that developer journey could be pretty daunting depending on where you started. We just talked about some of these prerequisite skills that you might need to be able to write some of these capabilities using ROS. Intrinsic, I feel, is helping accelerate this mission by completing these two journeys in a better way. The deployment journey, I think Intrinsic is positioning itself as this runtime framework for robotics, right? We have a product today called Flow State. It's a browser-based tool that lets you create a digital twin of a manufacturing environment, typically a small work cell with a robot arm, few sensors, etc. You can then program the automation in an intuitive manner using some skill blocks. So you can rearrange these blocks to orchestrate your robotic process. You can simulate on the cloud and then deploy on the edge, right? So this is like an all-in-one tool. Whereas if you look at the ROS ecosystem, maybe these tools exist, but the experience is a bit fragmented. You have to edit some launch files here, then you go run it, then you have to look at Arvis, and then you have to also look at Gazebo separately. So I would say perhaps that approach is great for development, and you can really develop at a much faster pace. But when it comes to actually production runtime, we're thinking about, hey, take all the stuff you developed there and look at the platform as a way to run this stuff.
Right.
And for other non-savvy developers, I think FlowState provides a good entry point into robotics. You don't need to know a whole lot about robotics
Mm.
and processes to be able to develop a process in FlowState. It almost becomes like you're playing a game. You have all these really powerful capabilities in motion planning, control, perception, and we're talking state-of-the-art capabilities here, right? So you're able to use these capabilities very easily to structure your program. And relying on these AI capabilities, you're even able to write very intelligent programs that don't need to change so often. It's able to handle a good variation of material and products and workflows. So the way I see Intrinsic contributing is by making this developer journey and the deployment journey much smoother.
Right. And I think that is the most important part because whenever we deploy the software on the robot, that's the main thing, the middle thing which every developer faces while deploying the
Yep.
software on the robot. And basically, whenever we are building a product, that is the main issue. So
Certainly. I think aspects that doesn't come to mind immediately are over-the-air updates. If you're a company that's shipping products out there, you might want to provide updates to people, right?
right.
So you can't everyone to do an app update or bash into the robot and make some changes. But over-the-air updates, versioning of your software, remote diagnostics, cloud logging, all of this stuff, it's going to be incredibly important for real-world deployments. And Intrinsic's making all of this much easier to do.
Wow, that's good. And one point that you mentioned about AI capabilities. So
Yes.
considering that point as well, and the AI trend which is currently going on, or else I will say advent of AI. So
Yes.
how ROS will move forward with it? Because some people are talking about software might get replaced because of AI, because even if we try to get some code, or let's say a ROS to node as well, we can get it easily using any AI. But of
Sure.
course, for hardware implementation, it's hard. Even I tried it out, but it doesn't work up to that mark. At the
Yes.
same time, still AI will evolve with time. So, what is
Yeah.
exactly? So,
Yeah.
how to survive in this particular time?
I know.
And
I'm worried for myself too. So let's get one thing clear, right? Today's models are probably the worst models we'll ever use. They're only going to get better, right? What's important is we as developers have a clear understanding of these models, the state of the art, and use them as tools, right? When calculators came out, nobody was fighting for logbooks, right? So think of it as ways to improve your quality of life and your efficiency. And what's going to get more important is creative thinking and systems thinking.
okay,
Being able to have this ability to architect systems. How do these different systems play together? How should they interact, etc.? I think it's going to become a creative process, most of the development. And I think
right.
this is where we could still stand out, right? Recognizing nuances in problems we are trying to solve, recognizing how best to integrate two or three systems together for an end-to-end solution. This is what we're good at. And we need to focus more on these abilities. And then AI could potentially make our development journeys a bit faster. So we can hand it over very specific blueprints. Like, here's what I want to develop. Here's how the system should look, like a product requirement
Right.
document. And perhaps it can quickly whip out either some functions or some modules or maybe even an entire node. That's fine. But you as a developer are still extremely mindful of the high level picture of how all these pieces come together.
Right. And that's actually a good thing because I think AI is, I think we are at the right time, I will say, because the generation which was behind us, they were not able to use AI
Hmm.
at the extent that we are able to use. Starting of the career, let's say, that's the best word. So I think we are in the best possible era. Instead of seeing
Yeah.
AI as a thing, it will take our
Yeah.
jobs. So I think it will create new jobs.
I think it can free us up to do more work as well. Maybe
Mm,
today you thought you can only write one ROS node. But at the end of the day, you've been able to write 5 nodes that all talk to one another because you
right.
spent most of your documenting
Mm,
the requirement
right.
and you spent a lot of time thinking about the architecture and the actual development you've handed over to AI. So it
Mm,
helps you do more progress as well.
that's true. I think my dream was to become an Iron Man, so that is going to be that
Next
is
time
going
we
to be
chat, I hope to see your suit.
for sure. I think it's a dream of every robotics engineer.
Oh, absolutely. I think that's usually one of the first introductions to
Mm,
automation and robotics, right?
exactly. Right. Whenever I conduct workshops in colleges while giving the robot examples, I keep this
Yeah.
Iron Man thing as well in my
Really.
presentation. That's really good, and it's a kind of fun activity though. But
Yeah, very ahead of its time. We're talking about agents today, but Jarvis decades ago.
right. So actually, we are done with the questions, but
Okay.
still, is there anything from your side that you would like to add?
I would like to double down and emphasize on the contribution part, especially among the Indian developers. What I noticed last year at ROSCON is the enthusiasm and energy is through the roof. There are so many people who are actively learning ROS, which was very
Mm,
nice to see, actually. There are a lot of people who are building really cool applications. But when I look at the project, I'm not seeing as many contributions from
uh,
people. I would love to see a shift from just being a consumer to also being a contributor. And I think it can be seamless, right? I'm sure as you're using the tool, you are encountering issues. The tool's not perfect.
Right.
And maybe you're opening a ticket, maybe you're not. So I want to say many things. First, do open that ticket, share your experience with other people, and maybe you'll realize that someone has already solved this, or maybe you get an answer to it. But I would expect, or I would request you to take the ownership to try to fix it yourself. Because ROS is federated, it's distributed, anyone can contribute to it. And don't think of yourself as any lesser compared to anyone else. Use this as an opportunity to learn, make the contribution, get some feedback, iterate, improve. And you'll find a good sense of purpose by doing this, right? The other thing I would say is work together with more people in projects, pool resources together and do projects together, right? That's the best way to learn. And same thing, when you do these projects, contribute the documentation back. But yeah, don't be afraid to get your hands dirty, get your feet wet, jump in there, do some projects together, keep the contributions coming.
For sure, definitely. And I think a lot more people will contribute after this particular podcast as well, because the insights that you give are really good for the ROS community. As you said about the contribution part, I think it's really good, because some events like ROSCon, where people got to meet with the new people, build some connections, got some insights, but now it's time to do the contributions as well. And also, I will also take this particular point seriously and to do
Yes.
the contributions by myself as well, by creating the tutorials, might be try to
And
contribute for the packages as
you can even work in your own packages. You
well.
can create a separate package just for the tutorial.
Right,
And you can make that public. You can distribute this through the build farm and share it with the community, either on Discourse or Discord. There's many avenues to get your work out there to people and get their
right.
feedback on it. So you don't hold yourself back.
Sure, of
Another point I
course.
wanted to make was about the importance of community. So one thing that makes ROS so popular is the community. I think it's a very, very unique community of people wanting to democratize robotics, put software out there for other people. And it's a very special community, in my opinion. But this community is not localized to any one region in the world or any few individuals. Even within India, India is a big country, right? So don't look for one or two people to lead the movement of open source and robotics and ROS there,
Right.
right? Every city, every state could have its own regional communities that can get together to work on stuff. So try to collect or organize yourselves into smaller groups, work on projects together. Maybe set aside some time once a week to just jump online, work on stuff together. Maybe everyone's just coding at the same time, but at least you have other people you can just quickly ask a question, maybe just pair program together or vibe code together, right? I think it's very powerful. And one other point I wanted to make was often there's this misconception among companies who are using ROS that if they contribute back to ROS, they are losing some IP or maybe some secret sauce is being given away. But I hope to see a shift in this mindset. You've built your product using ROS.
Right.
And if you think contributing like some fix to launch or maybe some small fix to RCL Pi is going to give away your secret sauce, I think you have to reevaluate what you're building, right? These are all tools that are helping you build a product that
Exactly.
adds value differently, right? And you are not going to lose any IP by making these contributions, right? So just think about what exactly you're giving away and whether it actually has an impact on the product you're building. Most likely it's not. And you'll see that actually engaging with the ROS community benefits you a lot more as well.
I actually like the last point that you mentioned about the companies who are trying to build products. I think they might lose the IP. And that's true in some part as well, because companies feel that because they think that the service they are providing might be some other companies might get it, or else the other people as well. But that might not be the case, because for the community as well, it's the best way to learn and grow. And even if we share on the community, we are at the end going to get the feedback from them.
Yes.
So we can improve instead of thinking that someone else will copy our code or replace the packages. So I think
Yeah,
it's the best way to improve.
I would 100% agree with that. The nature of the contribution is most likely not going to give away any IP or your secret sauce, right? Sure, if you're working with Nav2 and then you've really dialed down certain parameters, right? We're not asking to open source that. Yep, keep that as your special recipe. But maybe when using Nav2, you found a bug either in Nav2 or maybe somewhere upstream in lifecycle node, launch, gazebo, whatever it is, right? Maybe it's a simple fix, or maybe it's just a documentation fix as well. Telling people how to use it is not going to give away any IP. Certainly, I think it's to be clear on what has value for your product and what doesn't destroy your chances of succeeding. And I feel like most contributions fall in the other bucket. It's, of course, time. What the problem boils down to is time, especially in startups and companies. You have few resources. So perhaps dedicating these resources to contributing upstream is going to be challenging. But the way I see it, what companies normally do is they'll fork it or create a copy of this code and then apply the fix locally. And now they have this maintenance burden. Now they have to maintain yet another package internally.
Right.
So think of it as actually making more efficient use of your headcount. Instead of forking and then creating a copy and working with that copy, just upstream that change. And now the maintainership burden is back to the community or back to the original maintainers, and you get to build the software and it has the fix that you need.
That's actually a valid point, I must say, because for the companies and also for the developers as well, there are some individual contributors as well who are working on some hardware projects and developing some good things which are for the prototyping, but that might be converted to a product as well. So for both of them, I think so these are some important points to be remembered at the same time.
Yeah. And when you upstream these changes through a pull request, you now have the opportunity to interact with other developers. And these developers could become assets and allies for your team. Next time you have a question, you've built this relationship with the developer through this interaction.
Right.
You can reach out to them. You can get more insights and inputs from them. So I think it's really valuable for companies to build these sort of connections.
Exactly. So instead of wasting the time on, let's say, keeping the code as a secret, or else, as you said, we can keep it, but unless and until it's a kind of perfect recipe which is going to deliver the product, we can keep it as a secret. But if it's not, then it's a waste of time. We can just call out the community and get the team built, or else make the code at product level as well. So that's the thing.
And then lower the burden on your side. If you choose to fork and then fix the fork for just yourself, you have to maintain that code for the rest of your life. Right? Upstreaming it gets the change out there, and now it's back in the binary form. You don't have to worry about that anymore.
That makes sense. So with these points from your side, we will end this particular podcast. And Yadu sir, I will also add your LinkedIn profile link below so that if someone wants to reach out to you or else connect with you, they can definitely connect with you. Even if possible, if it is allowed, then I can add intrinsic link as well, or the website link in the description so that people, if they want to know about Intrinsic, they can just visit to the website and know about the company as well.
Sure. Thank you.